discuss about the structure analysis, in which we can talk about the indeterminate structure of the structure analysis. We can see different methods to solve determinate structure. What is indeterminate structure and other related this I can tell you about in this video. Okay. Basically we have many methods to solve indeterminate structure. The first method and most commonly used method is using force method. They can also used in different universities of structure analysis topic, and also in the field during the designing of structure of any type of building or others. So first is force method. So we can directly go start to the example, and then I can tell you with every step how they come. So basically example are: determine the direction and the ruler support B of the beam. Basically we have need to find the direction at support B. The actual beam behavior and all supports are diagram given. So solution, initially we have find what is indeterminate structure. Indeterminacy, we can check when the number of supports are greater than the equilibrium condition. Number of supports, how many, we can see that we can know that at fixed point we have 3 forces, which is this. At the roller support we have 1 force. This is same as it is at hinge we have 2 supports. Vertical, same as it is. We can see number of friction, how we can calculate. It's an initial step which we must have need to find, because if we don't know its indeterminate structure, then how we can solve. So the number of frictions are here given. You can see my mouse and follow them. This is number of frictions. Number of equilibrium condition we know 3, 4 minus 3 1. So we know that it's a first degree statically indeterminate structure. So how these come for A 1 2 3, you can see 3 arrows red and 1 at there. This is force. Equilibrium condition we know Ax, Ay and Az, 3 equilibrium condition. So 4 minus 3 we solve, and now 1 equilibrium condition. After that we can see principle of superposition. By take redundant. We have take redundant. Redundant mean you can remove this port. Okay. Removal of redundant By at ruler support By is remove By symbol to act upward. So it's a very simple way we have removed the ruler support. So you can see the behavior of this load. This curve can be shown. So when we remove this board, the behavior of this curve of loading, bending are like this. So how much this vertical distance is delta, it's a deflection, and after that it's actual beam structure and primary structure. It's a redundant By applied. Okay, you must have need to draw these 3 diagrams: actual beam, primary structure and secondary structure are redundant applied. We applied vertically By, so this bending behavior are going on upward. So this delta B are there, delta B By FB. Basically this equation we have proved already. There compatibility equation we can say that, and delta B FBB obtained using table inside the front of cover. Basically we have made this equation. So these equations are come from this structure analysis Hebler book. Okay, what is this 6 theta? We can say that this whole length is 12, so the deflection started from this point to this point, so half distance is 6, so we can add them 6 for theta are deflection, or you can say what are. So redundant structure are there same as it is. Now we can put this equation, how these two terms are come from. This I can say to the structure Hibbeler book. Basically this is the Hibbeler book I have opened. Yes, this at area at hinge point, at point load. So these are the terms which we take from this table to our questions. This is a structure Hibbeler book I have mentioned there. So now these two equations are come from. I can also say that now putting values. So P is the 50 applied load and the total distance 6, 3 EI, 50 PL, and whatever length are same. All things are putting in the given equations. Loads, P is the load, L is the length, and EI is the constant, and these equations are come. So now we are moving toward compatibility equation. So these are FBB come. FBB is the compatibility equation. So these values are put in the general equation of this. So now By values are come, which is 15.6. So now we know that By value is 15.6 kilonewton if we can apply and take redundant to By. So interaction plays in free body diagram. Free body diagram we have take this By structure. So these are the basically result of our to solve this structure. Now we need to draw shear force and bending moment diagram. You can must solve easily, but I can give you one trick more. You can just go to Google and here you can open the beam calculator. It's a smart mind trick which most engineers use. So at here you can put your length and your whatever your sport is, pin sport, hinge sport, roller sport. These are the sports, and these are the point loads. You can see point load and the 6 distance is 50. So now you can click run, and these are the shear force and bending moment diagram. You can see in any type of video. So I can also solve little much difficult example next video. So if you have any query or any other, you can tell me in the comments, and I'm very thankful to you. You are watching this, and now next I can in next video we can solve some difficult example, and after that we can move to next method, direct stiffness method of structure analysis. Okay, thank you and goodbye.